Okay, sorry for the earlier snafu. I hit stop when I should have hit pause, and I ended up getting kicked out, but it's all for the better. Sorry, this is going to be a long one. It's really intense when we start getting into these types of word problems. So this should be our fourth example. A person throws a ball upward from a 506-foot tall building. The ball's height, h, after t seconds is given by the equation h equals negative 16t squared plus 48t plus 506. The ball lands on a balcony that is 218 feet above the ground. How many seconds was it in the air? So let me draw a picture of this. So we get ground, we have a building, we have a person standing on the building. This building from top to bottom, so I'll write the number in here, is 506 feet. So from here to here. It says that the person throws a ball upward from a 506 foot tall building, and then the height after t seconds is given by the equation, and then it lands on a balcony that is about 200 feet above the ground. So here's the balcony, and it's got some sort of railing so they won't fall out, and the distance that it is from the ground is 218 feet. So that's from here to there. So the person takes the ball, and they say it tosses it in the air, and it lands on the balcony, okay? So the question is, how many seconds was the ball in the air? So you toss it up from the moment it left that person's hand. How long was it moving before it came to rest on that balcony? And no, I don't want to hear about, oh, it could have bounced. Nope, we're not going to deal with that. So we're going to take our original equation, and we kind of have an issue here because I see two variables, and I can only solve if I have one variable, unless I can make a second equation. But then I start kind of investigating, and I notice the similarity that we have feet, 506 of them, and that ends up in our formula, right? But then we have another feet, and that's 216 feet, and that's where that balcony is. So that number is actually representing the height after time. So it doesn't go to the ground, which would be a height of 0. It lands on this balcony, which is 218 feet above the ground. So the 218 is going to go here, and then equals negative 16t squared plus 48t plus 506. So we want to solve this by getting the everything on one side in descending degree order and 0 on the other. So I'm going to rewrite this using the symmetric property, and that gives me negative 16t squared plus 48t, and then plus, and then I'm going to have to do some subtraction. So over here, I'm going to have to rename, and I get 16 divided by 8 is, or take away 8 is 8, 9 take away 1 is 8, and 4 divided, take away, why am I saying divide by? So sorry, is going to give me a positive 288. That equals 0. So, I know 16 can go into 48 evenly. Let's see, if it goes into 28 once with 8 left over, or 22 left over, or sorry, try that again, with 12 left over, so I get 128, and let's see, if I multiply 16 times 8, that's 48, and 4, and yep, that gives me it. So yep, it's a divisible. Now, what I don't like is that the top number is negative, or front number is negative. So we're going to divide everything by negative 16. Now notice, when I divide by a constant, or a coefficient, it goes away. Because if I try to set that equal to 0, I'm going to get negative 16 equals 0. That doesn't make sense. So what I am going to make sure is if I ever have to factor out, excuse me, a variable, that variable will be considered part of the answer. Excuse me. So that leaves me with t squared minus 3t, and then minus, that went in, we said once, and be negative 18. Sorry, something went down the wrong way. Wow, that turned into a much easier problem to solve. So I need to think of factors of negative 18 that add to give me negative 3. So the two numbers are going to have different signs. And the two numbers would be negative 6 and positive 3. And that's going to give me that negative 3, and it's going to give me negative 16. Okay, or negative 18. So now I'm going to take that trinomial and make it into a 4-term polynomial. And we get minus 6t plus 3t. And then we're going to factor by grouping. Oops, let's put a color there. So that's going to give me a t, so I get t times the quantity, t minus 6. And then I'm going to pull out, these two have a positive 3 in common. And that's going to give me a t minus 6 equals 0. So I'm going to continue over here. Together, there is a t minus 6. And what's left behind is a t plus 3. And that equals 0. So I'm going to set each of those factors equal to 0 and solve. So I have t minus 6 equals 0, and t plus 3 equals 0. So we're going to do inverse operations to get the t alone. So I add 6 on this one, subtract 3 on that one. And I get t equals 6, and I get t equals negative 3. So does it make sense that we could have something be negative 3 seconds in the air? And the answer is nope. So we throw them out. And we would conclude that the ball was in the air for 6 seconds. Okay. All right, we got one more example. And this one you're going to have to not judge me for my horrific drawing skills. So this is going to be the 5th example. I think that's right. Yeah. So this one is, suppose a cheetah pouncing on an antelope. Pouncing. Oh, I'm going to go ahead and put this on. I'll put this on pause. Okay, so sorry I started writing when I had the volume on. But anyway, we suppose a cheetah pouncing on an envelope. Time to eat lunch. Antelope leaps with an initial upward velocity of 19 feet per second. How long is the cheetah in the air if it lands on the antelope's hindquarters 3 feet from the ground? Okay, so let me draw our antelope. Okay, that's an antelope. It's not a bug because it only has 4 legs. All right, and then we're going to get a cheetah. This one's even better. Can you see how it looks like a kitty cat? So what's happening is that this antelope is going to be heading this direction, running. And this cheetah is going to just leap in the air. Just leap. Not bleep, bleep, like I'm saying bad words. And what's going to end up happening is that you're going to have the antelope is like right here at this juncture. And by the way, those are its horns, not its antennae. And you're going to get the cheetah just getting onto the backside, the hindquarters of that antelope. Okay, so a couple pieces of information. And I should draw on the ground. That'll make it a little easier. So the distance the hindquarters is from the ground is the 3 feet. Okay, so from there to there. All right, now, first, the other thing I want to mention is velocity. Notice the label feet per second. So velocity is a fancy way of saying speed. Okay? All right. So we are going to be using the idea of a projectile. Okay? So in the last problem, we saw the equation written for us. We're going to write it again. So I'm going to put it underneath here, and I'm going to go, so the model of the height of a projectile. And the projectile in this case is the cheetah. In the last problem, it was the ball. So it is, generally speaking, h equals negative 16t squared plus v sub 0 t plus h sub 0. Okay, so first off, I think we've mentioned this before, that negative 16t squared, the negative 16, what goes up comes down, what brings it down? That would be gravity. So that's going to be your pull of gravity, is that negative 16. So let's define all of our pieces. So h is the distance something travels after time. So this is going to be the height at t seconds. Okay? T is time. And it's measured in seconds. Okay? If you remember that word, that 19 feet per second, no in front of it, it said initial upward velocity. Okay, so that is what the v sub 0, oh, I got to change that color. Sorry, I'm going to change that color. I'll make it, v sub 0 is going to be, oh, my colors aren't matching. Oh, well, the initial upward velocity. So in the problem we did before, the initial upward velocity was 48 feet per second, okay, because it had 48 in that problem. And then the last number, the h sub 0, is going to be the initial height. So where did things start from? Okay. So just as a reminder, if you are ever given ground, you're at a height of 0. So keep that in mind. Okay. So this is the basic. You've seen this show up in your homework a couple of times. Showed up in the last problem. So let's go ahead and put the numbers into this where it belongs. So we want to know what the height of the cheetah is. Well, it says that the cheetah is at the hindquarters, and that's 3 feet above the ground. So for our problem, I'll put it over here, we're going to have that the h sub h, the plane h, is going to be the 3 feet. Okay? Time is what they're asking us, how long. So time's going to stay t. So we're just going to have t. The initial upward velocity is that speed with which the cheetah is pouncing. So that's your 19 feet per second. And then the initial velocity, or the initial height. So if you think about it, where was the cheetah to begin with? The cheetah was on the ground. So that's 0. So let's go ahead and plug our numbers into our basic equation. So we're going to get the h is 3, and that's going to be equal to negative 16 is always going to be part of this, t squared, and then plus, and then the v sub 0 is going to be the 19, and then t, and then plus, and then the height that the cheetah started at was at 0. Okay? So now we're going to get everything on one side, 0 on the other. So I'm going to go ahead and subtract 3 from both sides. That gives me negative 16 t squared plus 19t minus 3 equals 0. So I'm going to play the game. And I have factors of positive 48 that add to give me 19. Okay, so let's think about it. Factors of 48. So the signs are going to be the same, and we can actually see them right there in the problem. 16 plus 3 is going to give me 19. So we're going to get a positive 16, and a positive 3. So we're going to go ahead and factor. So we have negative 16t squared. We still have minus 3. We still have equals 0. And those two middle terms are going to be plus 16t plus 3t. And then we're going to go ahead and factor by grouping. So the first two have, and I have to pull out the negative, a negative 16t in common. So I get negative 16t times, and I'm going to get t minus 1. And then we're going to have, for the second grouping, a positive 3 in common. So we factor that out, and we would get t minus 1 equals 0. So our little miracle occurs, and we get t minus 1 times the quantity, negative 16t minus, or no, excuse me, plus 3 equals 0. So we're going to go ahead and solve each one of those, set them equal to 0 and solve. And we're going to get, subtract, add 1 to both sides. This one I'm going to subtract 3 from both sides. So I get t equals 1. And then over here I have negative 16t equals negative 3, divide by negative 16. And I get t equals 3/16. So I have two different answers. So we go back, how long is the cheetah in the air if it lands on the antelope's hindquarters 3 feet from the ground? So if you think about the two answers you get, at this point, this is going to be the 1 second. But there was another time when he was exactly at that same height. It'd be something like this. So that would be the 3, that would be this time, okay? Now the question says, how long is the cheetah in the air if it lands on the antelope's hindquarters? So what we're going to do is say it's got to be the entire time. So that's going to be the 1 second is going to be our answer. So this guy is going to be the answer to the problem. So we would say the cheetah, or it takes the cheetah, this is kind of a frightening number, 1 second to reach the antelope. That's pretty fast, but they are extraordinarily fast. All right, and there you go. So have that done for Tuesday, and we'll see you guys then. Bye-bye now.